All right, now we're going to get into what we call compound inequalities. And compound inequalities, with compound inequalities, there are two types. You have or inequalities and you have and inequalities. First, we're going to look at an or inequality. All we're going to do here is graph this on a number line. So when you have a compound inequality, it's basically just two inequalities in one. So first I'm going to label my number line. And I have to make sure I include both numbers that are given. So I have to make sure it reaches 8, which I didn't make this long enough. Let's make that a little bit longer. Okay, then you're going to just graph one inequality at a time. So first, let's just look at x is less than -4. On this one, I have an open circle at -4, and everything less than -4 means I'm shading to the left. On my next inequality, and I'm going to change colors just so you can visually see, I have x is greater than 8. So at 8, I also have an open circle, but this time I'm shading everything bigger than 8, which means I'm shading to the right. Or inequalities should go out like this. They should go in opposite directions. And the reason for this is because it is either less than -4 or greater than 8. It cannot be both. There is not a number that exists that will be in both shaded regions. You cannot be both less than -4 and greater than 8. That's why this is called an or problem. Ors should go out. Our other type of compound inequalities are called and inequalities. They can be written with the word and, or you'll see them connected like this. This might look familiar to you with how we set up some of our problems for domain and range. When you're graphing this on a number line, again, you're basically just graphing 2 and 1. And so we're going to label it, making sure we cover every number, or both numbers. And then you can just look at it one at a time. So at -2, I have an open circle because that inequality sign is not underlined. At 3, I have a closed circle because that inequality is underlined. Well, x, always read it starting with x first, x is bigger than -2. It's greater than -2. So I would shade to the right there. X is less than 3, so I would shade to the left here. Basically, -2 is your starting point, 3 is your stopping point. And problems should go in like this because they're working together. You're both greater than -2 and less than or equal to 3. Some possible solutions for this are -1, 0, 1, 2, or 3. Anything in the shaded region. So here's an example of solving an or inequality and then graphing it. Whenever you have two inequalities in one, just focus on them one at a time. So first, I'm only going to look at 2x plus 3 is less than 9. I'm going to draw in my my algebra wall, and then I'm going to get x by itself. So first step is to subtract 3. I bring down the 2x. Second step is to divide by 2, and x is less than 3. Then I'm going to solve the second part. I'm trying to get x by itself. So first step is to add the 6. Second step is to divide by 3, and x is greater than 6. Then I would bring down the word or. This is my solution here. Once you have your solution, you're ready to graph it on a number line. So I need to make sure both numbers are included. And I'm going to graph them one at a time. At 3, I have an open circle because that one is not underlined. Less than 3 is everything to the left of 3. At 6, I also have an open circle, and everything bigger than 6 is to the right. So I may ask you to name a possible solution for this problem. A possible solution would be anything to the left of 3 or anything to the right of 6. So you could say 2, you could say -10, you could say 7, you could say 100. But some solutions that would not work are 3, 4, 5, and 6 because those are open circles or they're not shaded at all. Remember, ors should go out just like this. Now I'm going to show an example of how to solve an AND inequality. When you have an AND inequality, you have 2 and 1, so you have 2 options. First, you could just draw in 2 algebra walls, or if you want, you can rewrite this, separating it to be 2 different inequalities. Then you can solve each one to get your answer. I personally think it's easier to just draw in 2 algebra walls. So your goal here is to get p by itself in the middle. To start, you're going to distribute the 5. 5 times 3p is 15p. 5 times -2 is -10. And then I just bring down the -15 on the left, the 20 on the right. Your goal is to get p by itself. So whatever you do in the middle, you have to do both to the left and the right. So for example, to move the -10, the opposite is to add 10. If I add 10 in the middle, I have to add it both to the right and to the left. This becomes -5 on the left, 15p in the middle, and 30 on the right. Now all I have left to do is to divide by 15. If I divide by 15 in the middle, I have to divide by 15 on both of the outsides. When I do this, I get -1/3, I get p in the middle, and I get 2 on the outside. Now all you have to do is bring down your inequality signs. So from here, to graph this on a number line, and I'm just going to use this red line as my number line. To graph -1/3, I would just estimate that that's in between 0 and -1. We'll have a closed circle at -1/3. I have an open circle at 2. P is everything bigger than -1/3 and smaller than 2. Remember, ands